Dear student, in this video I'm going to talk about the refraction, okay, which is proven by the Snell's law. What is refraction? It's the bending of light. Do you ever wonder that when you put your pen in the transparent glass, okay, your pen is no longer looks like straight, it looks like bent. Why this happen? Whatever we see is because of the light. So in this process light bends because there are two medium. One is air and one you have water. So when the light enter into different medium, light behave differently. So Snell's law is telling you about the refraction, but before that we should talk about what is refraction. It's a bending of light. Why light bend? Just now I told you that when light passes from one medium, optical medium, to another, light used to bend. Is a similar thing like suppose if you're traveling on this road where there is no traffic, your speed will be highest. But in the same road, if there's a traffic, like bus, car, your speed will be slow down, right? So when the light enters to different medium, okay, suppose when it is entering from air to glass, the speed of light will slow down, and because of that light tends to bend towards the normal, and this bending of light is called refraction. For example, as you can see from in this example, light rays is entering from air to the glass. This is your incident angle, which is angle between the incident ray and the normal. When it enter to the glass, light speed slow down, so it is no longer going straight like how it should go without the glass. But since the light has some difficulty to travel, its speed slow down and it's bend, and this is called a refraction. Now whenever you heard this term optics, okay, it is the term related with the light. So what is the meaning of optically rarer medium? Optically rarer medium are the medium in which a speed of light is the more. For example, if you compare the glass and air, the air is the optical rarer medium. Just reverse it for optical denser medium. It is a medium in which the speed of light is less. Okay, so for if you compare water and the air, the water will be a optically denser medium. Why I'm talking that? Because we are going to always talk in this part when we discuss about total internal reflection. Now let's see the Snell's law. It says the first law that it is similar to the law of reflection. What does it say? That incident ray, normal, and the refracted ray, they also lie in the same plane. Now second point is very important, is tell you about when in the two given medium, just now we have discussed about air and glass, okay, the sine angle of incident to the sine angle of refraction is a constant. It means suppose if it is entering from the air to the glass, whatever the sine angle will be, and you divide with the sine angle of the refraction, you will get a constant. What is this constant? This is nothing but a refractive index. Now what is refractive index? Index means a value, okay, so this value will tell you that how much light is going to refract or bend when you travel in certain medium. So can I say that basically when it enters to in some medium, it will slow down, so refractive index will tell you that how much it is slow or more. So it's basically the ratio of the light travel in the vacuum divided by the medium, and in the vacuum light speed is a maximum, which is 3 into 10 power 8 meter per second. Okay, now just now we have discussed what that sin I by sin r is equal to constant. So can I say a relation that refractive index is equal to sin I by sin r is equal to C by V. This is a master formula to solving all kind of equation in this refraction part. So please think, and it's also logically, okay, it means what more will be the refractive index, the velocity of light will be low. Why? Because it is the denominator. As you can see in the diamond and the water, the diamond has high refractive index than the water, so light speed is slow down, it means it is bent towards the normal. Now let's see a chart of it. If you look this part, okay, you have a diamond, glass, water, ice, and air. Air have refractive index closer to 1. It means what? It will be highest light speed in this all the medium, which is closer to the light of speed in the vacuum. And diamond, since it has refractive index more, the speed of light will be less. I hope this is clear. You can pause the video and think of it. Now let's see some of the question. Okay, so question is that The speed of light in vacuum is this. Calculate the light in the refractive index. Just now we have discussed that refractive index, which I used to write by mu, is equal to light in the vacuum divided by light in the medium. So what will be light in the medium? It will be C by mu, which is nothing but 3 into 10 to the power 8 divided by 1.52. So if you cancel out, it will be your 2. So it will be your 2 into 10 to the power 8 meters per second. Now let's see the next question. So there's a glass slab. Okay, for refraction part or any problem when you're solving for glass, you should always think which boundary you're talking. Or you should think here there are 4 boundary: PQ, QS, RS. Okay, so you have to focus on what boundary they are talking. So question number 1 is talking about angle of refraction R at the air glass boundary. It means boundary PQ. Now what should be the angle R? So I used to very simple technique, that whenever there is incident angle, okay, you take that refractive index and multiply it. What I'm saying, that refractive index of air, why? Because light is incident in the air, multiply by sine of incident angle will be equal to refractive index of where the refraction is happening, means glass, multiply by sine of the refraction angle. Now what is the sine R here? If we get solve with this, so this will be your 1. Okay, let's solve step by step. So refractive index of air is 1 into sine I is equal to sine 60 is equal to refractive index of glass is 1.5 is equal to sine R. So R will be sine inverse sine 60 divided by 1.5. So when you solve this part, you will get the value around 35.3 degree. So question 1 is done. Now question number B, what is the angle of incident X in the glass block? Okay, so you can solve this question in multiple way. Okay, one similar way is that, see, this is a parallel line, this is a parallel line. When parallel line is intersected by a line, okay, the alternate angle will be same. So if this is X, this will also X. So R and X will have the same value. So this will be also your 35.3 degree. Now how to solve question number C, which is the talking about RS boundary, this boundary. Okay, very important, you can solve it here in this way, that the light follow the principle of reversibility. What is reversibility? It means if I'll reverse this light, suppose if light is going from here air to glass, it will bend. Now if it is enter out of glass, it will be follow the same pathway, right? Means if it is the 30 degree, it will be also 30 degree on similar. Now if the light, if you reverse this pathway, if you put the light in this way, it will follow the same pattern. Okay, so to solve this question, I can assume that light is entering in this direction. So this will be our incident angle for this surface. So I will write in a similar way, refractive index of the air multiply by incident angle in the air, which is y, sine y, is equal to refractive index of glass multiply by sine x. Correct? What is sine y? It should be 60, because you know this is in air, this is air, so it will be your 60. So in that, if you calculate the y, it will be your sine inverse refractive index of glass is 1.5 and sine 60. So if you solve this part, you will get your answer that y is 60 degree. So you can check your answer and you can let me know how much you got. And okay, 1 minute, I did some mistake. Yes, it should be here 35.3, not 60, because x is 35.3, right? So sine 35.3. And without going that also, you can solve it based on reversibility principle, that if it is 60, obviously y will be also 60. You don't need to go through the longer route also. Now let's see some more question. Okay, like this. So light is entering from air to glass. Okay, what is the question telling you? Shows a ray of light being partially reflected. Okay, very important. Whenever there is a reflection, means it is light is coming back to the same medium. So if it is partially reflected at the surface of air and glass, it means this part is your reflection and this part is your refraction. Now in reflection, you know that sine I, not sine, angle of incidence is angle of reflection means if it is the 30 degree, x will be also your 30 degree. So part A is done. Now part B, it is the refraction part. So let's talk about refractive index of air multiplied by sine I is equal to refractive index of glass multiplied by sine y. So this is your 1 multiplied by sine 30 is equal to refractive index of glass is 1.6 given here into sine y. So y will be your sine inverse, yes, sine 30 divided by 1.6. If you solve this, you will get this value around 18.2 degree. You can pause the video and solve it. I think you will get the same answer. Now let's see little complex scenario where you have multiple different medium. Okay, like here if you look this question very carefully, what is telling you, figure 10.8 shows a path of the light ray xy. This is your x to y through the fish tank filled with water and glass. So they are different medium. Here you have air, then you have a glass, then you have water. There are 3 medium, right? And every scenario the light will behave travel in different way. So they want what is theta and what is alpha. So theta is the refraction angle formed in the glass. So let's talk about the plane AB, which is a plane between air and glass. So at AB plane you have where the incident angle is happening, it's in air. So refractive index of air multiplied by sine 60 is equal to refractive index of glass multiplied by sine of refraction, which is theta. So theta will be your sine 60 sine inverse, yes, sine 60 divided by g, which is your 1.5. So if you solve this part, you will get around 35.3 degree. So part A is done. Now what is alpha? Okay, for alpha, since it is in air, it is in water, it's easier to follow the reversibility rule, that you assume that if light will incident from the air, it will flow for the same pattern. So if light flow from the y to r, then the incident angle will be in the air. So for part alpha, okay, you have to think this is your plane B and you can write CD for CD plane, right? For CD plane, refractive index of air multiplied by refractive sine angle 60 degree in the air, then refractive index of water multiplied by the sine alpha. So air 1 sine 60 is equal to what is the water, you have 1.33 into sine alpha. So alpha will be sine inverse sine 60 divided by 1.33. So if you solve this part 1.60 by this, you will get around 40.6 degree. So you can pause the video and try to get this to value, and if you can do it, means you understood the part. Now let's see some more question which is you can solve by yourself. So you can pause the video and let me know what is your final answer. I hope you got it now. So question number 4, what is the refractive index of liquid? So first you have to figure out what is the sine angles. This is your 60 degree. What is the refraction angle, which is the 40 degree. Why 40 degree? Because angle from the normal, if it is 50, it should be 40. It means refractive index will be your how much? It will be your C, option number C. Now let's see next question, number 5th one, that a ray of light is traveling from one side from air to glass. So this is very simple question. They are asking you which is correct option. So you know it is going from air to glass, so it will be bent towards the normal. So this option is gone because it is going away from the normal. Okay, this is also gone because this is not correct, because if it is entering again to the air, it should be behaving like similar way like how it is in the air. So this is gone. This is exactly to normal. This is also gone. So only option number D is the correct answer, which you can see here. Whatever angle is here is the same angle here, it is bent towards the normal. So option number D. Now let's see one more question which you can solve it and let me know via the in the comment box. What is refraction? Just now we have discussed that refraction is the bending of light. You can write in the detail. Here in this question they are asking you to determine the refractive index of glass. So how to figure out refractive index in the glass? So they are going from air to the glass. So refractive index of air multiplied by sine 30 degree is equal to refractive index of glass multiplied by sine 20 degree. So refractive index of glass will be nothing but sine 30 divided by sine 20, which is very simple, you can solve it. Next, state y, x and y. So this is your x, this is your y. If you think this is the parallel line, so they are alternate angles. X will be your 20 degree. What is y? Y you can follow the reversibility principle, and y will be your 30 degree, because if this is the 30 degree, this will also 30 degree. You can prove by the another way. So this is one way to solve it, that emergence angle will be the same. Another way to prove is by the light of reversibility, means I assume that light is going in this way. So if light will go in this way, means I am talking about the second way, where I am assuming that light is entering from this side, okay, and it is making the angle y. Yes, and it will be bent toward the normal. So this will be your x. Oh no, so I have done some mistakes. You can try to make it. So I am entering this part. Okay, so second way is that I tell you about refractive index of air multiplied by sine y is equal to refractive index of glass multiplied by sine x. So x, you know, it's a 30 degree. Refractive in glass, you know, you have solved from this part. So you can put here the data, put the sine 30 and figure out your y. You will get the same answer. I hope this much explanation is good enough to understand the refraction part. So you can solve some of the more questions. So this is as a homework. You can solve this question and you can write in the comment box. I will say it. If you like this video, you can press the like button. You can share with your friend. If you have any comment you want to discuss, you can say to me. We can discuss about that.